Alright guys, this is a video on Docker Compose. You are not gonna believe what we're gonna learn in this lesson. And with one touch of the button, we are gonna execute one command that will launch hundreds of containers over private networks with environment variables and custom settings, and it's all scalable. And we're gonna teach you all of this in this video. Isn't that amazing? You're not gonna wanna miss this lesson on Docker Compose. Now we're gonna take a look at Docker Compose, and its core feature is to build up projects and tear down projects. Now a project can contain multiple containers, lots of settings, and lots of information. Now, are you gonna remember that information? Is it gonna be accurate? If the settings are off, potentially other containers can be thrown off and other programs can be misconfigured. The idea of having a Docker Compose project is that all of that is pre-configured for you, and you just run one simple command that boots it up or tears it down when you need it. And as you don't have infinite resources on your host PC, you can simply tear down a project to free up memory and CPU cycles for your other projects. So let's go ahead and take a look at a standard project. We have our Avelx Academy lesson root directory. Now remember that name, as that's going to be a very important name when it comes to seeing how Docker Compose executes. The next thing we have is the Docker Compose YAML file. Now the YAML bit, you can change that to JSON. You don't have to stick with the YAML format, but what you need to make sure is in the root directory, that file is named docker-compose. If you don't, Docker Compose is going to try and look for this file. If it doesn't see it in the current directory your terminal is in, it won't be able to execute. So you'll have to actually define that custom name. So to keep things simple, just type in Docker Compose. We're using the YAML format and it's very simple to read. So the first thing you'll notice is that we have services. Now I want to stress that services are different from containers. Now I'm going to explain why they're different and what they actually do inside of the virtual network that Docker Compose will create. And if you're a little confused, don't worry. I will show you. So you define the services, and the services you're running is right here. We have Postgres, then we have the backend, and then we also have the front end. Your service names must be completely unique in that file. And the next thing is each one of these services is going to run an image. It's going to have containers running inside of the service. You can have one container or multiple. At the moment, it's just one container inside of a service. And you're going to define, just like a container, what image do you want to run. Then you can configure the ports, as of course we do here and here. And you can optionally define the environment variables. So for example, with Postgres, you need to define the Postgres password variable. Otherwise, it will simply error, and Postgres says, I won't boot up unless you've got an admin password, for security reasons. All your environment variables can simply go under environment. You could just keep adding new line after new line. You also have volumes. I first define the volume and then where I want to mount the volume. Again, this makes sure that the data is persistent in the database. So if the database container is destroyed, the volume will still exist. You'll also notice at the bottom of the manifest file, we are actually telling it to create the Avelx data volume and to be aware of it. If the Avelx data volume exists, it won't create a new volume, but if it doesn't exist, it will create one where there isn't. So that is basically where it's pointing to there, yeah? Avelx data. And then after that colon, you have simply where you're mounting this volume. Nice and easy. I don't have to remember all of these settings now. All of these settings are pre-configured in my Docker Compose YAML file. I have my services, I have my images, and I have my volume. I also have environment variables that I need to define. And this is going to save a truck ton of time. Now we're going to take a look at the terminal. The first thing we want to do is type in pwd, print working directory. Inside of the print working directory, you'll notice it says Avelx Academy lesson. Now what we want to do is we want to actually run this Docker Compose project. So we're going to do docker compose up. It's as simple as that. And it will look for the Docker Compose file. So you'll notice here, it's actually created a network, which we're going to elaborate more on that network in just the next segment. But this right here has shown us that it's created 3 containers, Postgres, front end, and back end. And check it out. Right here in the Docker desktop, you can see Avelx Academy lesson is the stack name, again coming from the root directory name. And then you also have Postgres, front end, and back end. Excellent. And they're all up and running. Everything is hunky-dory. Now, in order for me to get rid of this, we can simply type in docker compose down. So instead of up, you tear it down. Simple as that. It's now removed those containers, and it's also removed the network as well. Now, the network is going to sound like a little bit of a black box. What is services? What makes that different to a container? What is this virtual network that it created and destroyed, and how is it defined? What does it do? Now, Docker Compose might seem like a little bit of a black box until you learn this next segment where we're going to take a look at the network of Docker Compose. All right, so now we're going to take a look at virtual networks. And if you don't understand virtual networks, Docker's going to seem like a little bit of a black box. So to help demystify this, consider your home network, which probably consists of a router and then all of your devices connecting to it, like your laptops, phones, and other computers. And these devices have an IP and ports allocated. And so programs running on that device can listen for data on certain ports. Now consider this in the virtual sense. It actually exists within your computer. It's not a literal network. These virtual networks, instead of there being devices, they are containers. And each container is considered as its own separate device, its own environment to run its own applications inside of. And you have the network itself, which is the router. That is essentially Docker, and it uses different types of networks, but mainly it's there to just simply route traffic from your host PC into that virtual simulated network inside of your computer. And you can have as many of these networks as you want. In fact, Docker Compose sets up a default network per manifest file that you run, so that whenever you run a Docker Compose up command with a different manifest file, a default network is created for that project. And so that helps further isolate your environments or your projects so that they don't get compatibility issues and it's a bit clearer to understand. Now, we also have the ability to scale. This is where services come in. Now, with these virtual networks, they don't have the standard Docker container and you just talk straight to it. That's a standard Docker virtual network, and you can make as many of them as you like. But the Docker Compose virtual network has services inside of it. A service is a little bit different. Think of a service as wrapping around the container. And you're probably going to ask, why is a service wrapping around the container? Is it making it easier for containers to talk to each other? Well, yes, you are using the service name for other devices on that virtual network to speak to other services. However, there is something else that's really great about services. Services allow you to scale. So let's say the front-end project is being accessed way more, and our local virtual network is being pounded on the front end, that this container simply wants to explode. Well, we need to balance the load to that container. So that's where services come in. Services can have one or more containers. The containers must be of the same image or type. But the service allows you to duplicate the containers. And when traffic is sent to the service will automatically start passing the data out onto different containers that are currently idling and just pass data around to share the workload. So you see how this allows for scaling. And so when a certain aspect of your project is accessed, you can scale with it. Let's take a look at our project. Now, the first thing you can see is that nothing has changed in terms of the manifest file. The manifest file is in fact exactly the same. The magic comes when you're actually in the terminal. So what I'm going to do is say we've got docker compose and then we do up. Now I want to tell one of these services to scale the front end. So we do -- scale. Then we say front end. And finally, we say how many times do you want to scale that service? So in our case, we want to scale it by 3. And this will help balance the traffic for the front end. So as you can see in the logs, you can clearly see the network has been created and it's also created these containers. Now let's take a look at this in Docker Desktop. Can you see now in the Docker Desktop, you have front end 1, back end Postgres 1, and we also have front end 2 and 3. So you see how that dynamic naming comes into it. They're not just front end or back end or Postgres. They can be, but when you're running multiple containers, it starts giving them iterable names, front end 1, 2, 3, for example. Now there's another problem with this. You have 3 containers. And all 3 of those containers are trying to access the same host port. Now, the issue is you only have one PC, one host that's running that virtual network. So on your host port, those 3 containers can't all access the same port. As anybody knows, if you try to run a React project on port 3000 twice, you're going to get an error. Well, it's exactly the same thing. So in reality, what you actually need to do at this point is we need to say, don't set a host port for the front end. So go into the manifest file, and right here, we're setting a host port of 3000. But we've got 3 containers now trying to access the same host port. That won't do. So what we do is we simply delete it. Now what we're saying is we only expose port 3000 on each one of those containers, which is absolutely fine. They're containerized environments. They're like their own devices. However, on the host PC, we now want to dynamically allocate the ports so that Docker Compose will take care of this for us. So likewise, what we can do is exit out of that and say docker compose down. Then I want to go back and say docker compose upscale front end 3. Now we will get less of an error. We can go back into the Docker Desktop and you'll notice that front end 2, 1 and 3, they are all now running and you're able to click on them and view what ports they are running on the host PC. So this one is running on 53258. Services allow you to scale. And this is something with container orchestration that's with most orchestration tools. You also have other tools like Docker Swarm and Kubernetes. But services and understanding services is crucial to getting rid of that mental block. And understanding virtual networks is incredibly important to understanding containerized environments because that is their communication layer. And services allow for scalability. So there you go. You now know that if you want to scale, all you have to do is type it in the command line and you just say scale up this service. And if I wanted to scale up the backend service, I could say scale backend and increase that to 2. But if I do this, I need to make sure that I'm not setting a static port on the host PC. We need to be able to dynamically set it. And the way to dynamically set that is to simply just delete the host port. Then Docker will assign one automatically, and it will only assign a port that is actually available on your host PC. Very clever. Now, you're not going to want to miss the next bit because we're actually going to take a look at the boot up process. This is something that's really important, and if you don't boot up these services in the right order, you potentially could receive errors in your applications. Don't go anywhere. All right, so now we're going to take a look at the boot order. Have you ever had a WordPress site and it can't connect to a database? Will the back end of WordPress not error? It won't be able to find the database. So when we Dockerize, let's say something like WordPress and the database, we need to make sure that there is a correct boot order in order for us not to get an error. That's exactly what we're going to do in our project right here. in Docker Compose, we have a Postgres service. Next, we have the backend. The backend will depend upon the Postgres service. So all I need to do depends on the Postgres service. Now we are saying that this backend service is now relying upon Postgres. Now we want to make sure the front end doesn't boot up without the back end, because again, the front end is going to be pretty much useless if we don't have all those blog posts and all that information that we can get from the back end, which we'll get it from the database. Again, we're going to say depends on, and then the service name, which is backend. So now this front end service is going to rely on this back end service, and the back end service is then going to wait for the Postgres service. That's how simple it is, and the boot order is very important. So now all I need to do is docker compose up, and it's as simple as that. It creates the network, and it also created these in order. It created the network, then it created Postgres, then the backend, then the front end. How great is that? So simple in Docker Compose. Now the next bit is going to be even more interesting, because if you don't understand this next principle of Docker Compose, you're going to be left behind, because this is something that's really powerful, and actually quite a few projects do implement multi-dimensional projects or networks and combine them together. And I'm going to show you how in Docker Compose. So what if you have a more complex project? And this happens all the time, where you have a front end, but this front end connects to multiple backends. For example, WordPress handles the blog posts, and then Drupal handles user management and content pages. How do you combine this and compartmentalize this correctly in Docker Compose? It's actually a lot easier than what you think it is. So the first thing is we want to create two separate networks, one for WordPress and one for Drupal. But then the front end needs to be able to access both of those networks in order to access both of the backends. Let's take a look at how we do this in this manifest file. So as you can see, we have all of these services from Drupal backend and the WordPress backend, but you'll notice we only have one front-end service. The front-end service again depends on WordPress and Drupal, so we literally have two dependencies for the front end. And now what I'd like to do is I'd like to create a separation of these. I don't want all of these containers running on one virtual network. I mean, it will run okay, but let's go ahead and compartmentalize them. At the bottom of the file, type in networks, and then you want to define the network name. So the network name for me is going to be WordPress, and the other network name is Drupal. You can also add settings underneath there. However, we're just going to stick with the standard virtual network, and you've actually literally told Docker Compose to now create two virtual networks. And now what we want to do is with the WordPress DB and WordPress, we now want to allocate these services to a network. So we're going to say networks, and the network we're allocating these services to, you guessed it, is WordPress. Then you also have Drupal, and with Drupal, we want to allocate that to the Drupal network. Okay, so now that we have allocated this, we've now created two separate networks and allocated those services. But the front end is different. We're just going to say networks again, and this time we're going to type in the network name WordPress, and the other one is Drupal. That's how easy it is to allocate a single service to multiple networks, and the containers running inside of that service can gain access to multiple networks, which is exactly what we need for this front end. Let's go ahead and run this. Docker compose up and see if it works. And there you go. It now has set up all of those containers. And if I go into the Docker desktop, you will see that the stack and all the containers are running. Now there's only one problem with this. We can't actually see what networks they're running on, and I've even tried adding the column and it's not in there in Docker desktop. So what you actually need to do is use the docker compose ps command. This will list out all your Docker Compose containers that are running, but we also need to format it. So you need to do -- format, and then in the string say we're going to format the table that's produced, and the first column that's produced is I want the names of the containers. The next column in these double braces, I want the network names. Once I hit return, you will notice we get the names. Okay, so this is Avelx Academy Drupal 1, and this is Avelx Academy lesson, and then it actually appends the name Drupal, the network name, to the end of the hyphenated name, and that name is based on your root directory name. So we've got a network called Avelx Academy Lesson Drupal and Avelx Academy Lesson WordPress. Fantastic, and you can see which container is allocated to which one. Now, I just want you to focus on this. Avelx Academy front end. Okay, we're looking at the front end. Do you notice here that we have Avelx Academy lesson, WordPress, then we have a comma, and then it also shows you the second network, which if I just scroll across, you'll see is Drupal. So WordPress and Drupal, the front end is shared with, and that's literally how easy it is. And that docker ps command can be very useful for figuring out where you're going wrong, potentially if the front end's erroring and it's saying it doesn't have access to certain containers. You need to know where your containers are running and what access you have. Alright guys, so I hope you've had loads of fun watching this video as I did creating this video for you, and I hope you enjoyed it. So if you'd like to join the Avelx community, check the link down below. This academy is going to teach you everything like condensing 20 years of my experience down into small, nice bite-sized snippets, and it's got a nice flow to becoming a full stack developer and understanding the ins and outs and really just condensing all this information down, saving you loads of time, and it's full of passion and love for the technological sphere. So thank you so much for watching. Click that link down below. Go ahead and join us on some courses on Avelx Academy, and of course like and subscribe, and we also have some other Docker fundamental videos right here.